Hello, this is Dennis Resnick, and this is the session Hidden Gems of SQL Server 2019. Today we'll talk about some very interesting yet not well-known features of SQL Server. Few words about me. I live in Kiev, Ukraine, work as a data architect at company Intap, and have been Microsoft MVP since 2010. I'm a big fan of SQL community, and I'm trying to do my best to develop and evolve this community in Ukraine. Now our agenda. SQL Server 2019 has a lot of big features. I call them killer features. Which are the biggest selling points for SQL Server? They are pretty well known. A lot of articles was written about them. And here are the features: big data clusters, hybrid buffer pool, SQL Server on Linux improvements, intelligent query processor, Java support, and so on, including string truncation error message. This one was considered as a hidden feature before a lot of articles about it appeared in the internet, and now I think this is not a hidden feature. This is a well-known feature of SQL 2019. And in this session, we will concentrate on the following hidden features: lightweight query profiling, including last query plan, DBCC page improvements, ideal workers count, reduced recompilations, and query optimizer compatibility level. These 5 features will be our agenda for today. You might ask me a question: why should we care about that hidden features? If they are not well known, maybe they are not important. And I would like to answer to this question with the following quote of famous writer Anton Chekhov. If in Act 1 you have a pistol hanging on the wall, then it must fire in the last act. This is a dramatic principle that states that every element in a story must be necessary, and irrelevant elements should be removed. In the context of this session and hidden features of SQL Server, this means that if this feature is inside the engine, then someday, sometime, it will be useful to you. It may help you to solve your task. It may help you to find the root cause of the issue. It may help you to do some performance tuning, and so on and so on. But this is very important to know about this feature and how you can use it. This will be the goal of this presentation, to look at these hidden features which might be useful. And I would like to start this presentation, this session, from the hidden features importance story. I'm doing this session about SQL Server hidden features since 2014, and in 2016 there was a feature input buffer. I have included it in the presentation, but at the time when I did that session, there was no use case for it in my practice. But later, about 2 years ago, my client, quite big retail company, called me. It was Black Friday, and asked to find the root cause of the issue. They had 100% CPU utilization, and that affected the sales very much. They are literally losing money because queries were not executing. And I would like to start the session from the hidden features importance story. I am doing the sessions about SQL Server hidden features since SQL 2014, and in 2016 there was a feature called input buffers. I had included it in my session, but at that time there was no use case for it, and it looks pretty useless, honestly. But a few years ago, my client, pretty big retail company, came to me on the Black Friday and asked to help them to find the root cause. They have 100 CPU utilization on the server, and their sales almost stuck. So they are literally, they were literally losing money at that time. And with the help of this feature, input buffers, we were able to find the root cause in 15-20 minutes. That actually saved their Black Friday, and they were able to fix the issue. I would like to start the session from the hidden features importance story, and particularly I would like to start the session from the hidden features importance story. That was a real example from my practice. I have been doing the sessions about hidden features since SQL Server 2014. And in 2016 session, I included the feature called input buffer. At that time, there was no use case in my practice, and honestly, this particular feature looked pretty useless. But 2 years ago, my client, pretty big retail company, called me on the Black Friday and asked for help. They have about 100% CPU utilization on the server, and their sales almost stuck that time. So they were literally losing money in the real time. And with the help of this feature, input buffers, we were able to identify the root cause in 15 minutes. And in an hour, they have fixed the issue and the sales continued. So that actually saved Black Friday, and that was pretty good example of the hidden features importance. Let me show you what was happened and why this input buffers feature was important. Here I have some workload which burns CPU, and let me run it. Now I'm going to the SQL Server and trying to understand who is burning my CPU. I'm getting data from VM exec requests about the current queries and join it with SQL text to get the text of that queries. And what I see here, I see something like this: create function, get multiple orders count. But this doesn't answers me a question, who do this load? Because this function can be used in hundreds procedures across the server. And in that particular case, we were not able to modify all the procedures to remove this function or to rewrite this function to some lightweight logic. But some of the procedures were definitely more important than others. And in some procedures, we were able to replace this function to some more lightweight logic and reduce the CPUs. But we need to find for which procedures we can do this. So, let me take some session, ID like 132. It's pretty old command, but it's still in SQL Server Engine, DBCC input buffer. It helps us to get the input buffer for a particular session. And when we will run this, we will see that for session 132, the procedure getClients called that function which produce load on the server. And there are a few issues with this command. First of all, it requires sysadmin permissions, which is not always available to you. And second, you can run it for a single session. And this can make the troubleshooting pretty heavy. Well, probably I can write some code which will show me input buffer for all sessions, but that will take some time and this will be not very efficient. Alternatively, in SQL Server 2016, Microsoft added the function which called exec input buffer. It requires two parameters, session ID and request ID, and it returns results as a table. Yeah? And I can see all the input buffers for the sessions on the server. And this is pretty cool. You see? I see getClients for almost all events, and I can do a lot of things with this data. I can group by event info and we'll see the actual workload from each procedure. Right now I have just get clients, 100 events, and probably I need to modify this procedure to alleviate the load. At that time, we were pretty lucky that not important procedure was taking almost all the load, and we were able to optimize it and reduce the load on the server, keeping the original function execution for the critical parts of the application. That was pretty cool, and this is a very good example of how hidden feature can help you. And now we're going to the second hidden feature, lightweight profiling. Okay. The story of lightweight query profiling started in SQL 2014 with the view dmexec query profiles, which allowed us to see the execution statistics for each node of your query plan for the particular query, logical reads, amount of rows, and so on and so on. And based on this, later with new release of Management Studio, we've got live query statistics, which allowed us to see this data processing in the real time in Management Studio. There were two prerequisites. You need to enable statistics XML or statistics profile on session level, which makes this approach pretty fine for troubleshooting single query, but not very useful to see bigger picture or troubleshoot more queries on the server. And this infrastructure of lightweight query profiling evolved during the time, and in SQL 2016 Service Pack 2 we've got an option to enable lightweight query profiling on the server level for all the queries with the trace flag 7412. The overhead of this is not very big, and in mostly cases I've used it, it was fine. So, why we're talking about this feature in context of SQL Server 2019, if it was already there in SQL Server 2016? This feature continuously evolves, and in SQL Server 2019 it was developed to the level where it can be enabled in SQL Server by default, and this is what is happening in SQL Server 2019. Lightweight query profiling is already enabled by default. Also, we've got database scope configuration option last query plan statistics. Even if your query was already finished, you can go and check the last actual execution plan for that query, which is really cool in context of troubleshooting. Getting the active statistics actual execution plan is really crucial in troubleshooting and optimizing the SQL query. And you can read the full story using this link, where all three versions of lightweight query profiling described, and the current version in SQL 2019 is really good. I have a procedure get post by owner or date, which is pretty heavy, I know this. Let me run it. Now I want to check what is happening in my server, and with plain old approach I will use view dmexec request to check the statistics of my currently executing queries. We'll join it with SQL text and query plan to get more information, but let's check how useful is this information. I can get the procedure text, which is pretty cool. I can see the actual query. I can get the query plan, but this is the interesting thing here. This is what we store in the query plan cache. This is an estimated plan, and I see just estimated number of rows and all other kind of stuff, which can be considered as a not bad starting point, but for actual troubleshooting, in mostly all cases, I need the actual execution plan and the actual execution statistics to understand which parts are slow, where we have or have not misestimate, and other kind of stuff. So to troubleshoot this query, I actually need to run it by myself in Management Studio, get execution plan, actual execution plan, and think how to optimize it. For long-running queries, this can be very time-consumable. And right now, in SQL 2019 and in older versions of SQL, we have this function, dmexec query statistics XML, which requires parameter session ID. Let me run it and show you the information which we get here. Query plan. And when I open it, you see, I see not only the estimated number of rows, but I also see the actual number of rows, which is really cool. I can do a lot of things starting from here. I can already understand what is slow part of the query, how can I optimize it, how much time I have to wait until this query will finish. Yes, this is not very precise estimation, but I know the number of rows in the table, I know how much data will be processed here, I know how much data have already been processed. So I can do a lot of things with this information, and this is really cool. I don't need to run this in Management Studio by myself. I don't need to make some false assumptions. I see the actual execution information. When I run this query, you see that number of rows is about 9 million. Let me run this query again. Right now, it's 11 million. So this statistics is updating in the real time, which is really cool. And by default, in SQL Server 19, it is enabled for all the queries on the server. So this is the real power of lightweight query profiling. And for me, it's a very big and major feature of SQL Server 2019. And now I want to show you one more cool feature which came into SQL Server 19 with lightweight query profiling infrastructure. It's called last known query plan. So I'm not sure if it's enabled by default, but definitely you can enable it with the following script. Set last query plan stats equal on. After this, the last actual execution plan for your queries will be saved. Actually, statistics for the execution will be saved. And let's imagine this case. Right now I don't have any active queries on my server. That means that if I had some heavy query execution, I already missed it, and I can't get it with query statistics XML function. SQL Server 2019 introduces new function, exec query plan stats, which requires plan handle as a parameter. I will also select the estimated query plan with the plain old view exec query plan. Okay. Let me show you this. I'm filtering everything by some filter. In my case, my query should access big transaction history 2 table. And let me show what I have here. So, I have estimated plan, and it looks pretty simple. Nothing is going to be bad with this plan. But when I will go to the actual plan, wow, I will see these very big arrows. And probably the problem is here. Estimated number of rows is 1, but actual number of rows is 30 million. Probably we have some statistics issue here. First of all, I will check the statistics for big transaction history for my predicate, if it's good or bad, if it's actual or not, but definitely this query plan is not very efficient for the data we have. And as you saw, using estimated query plan, it's very hard to find the root cause of the issue, but with actual data, with actual statistics, wow, we can do this very quickly. And this is a power of last query plan stats. And And that is really cool, isn't it? Next cool hidden feature will be the DBCC page improvements. For this demo I have some workload which will run several queries on MySQL and create some load. And let me run the query and check what is happening on the server. You see, I'm checking from DM exec requests and joining it with exec SQL text to get the actual text. And I saw that almost all my queries are waiting in page large update wait on this page 212. So now I need to troubleshoot what is this page, and I will run the DBCC page to find out this information. Database 2, this is tempdb, file 1, page number 2. And detailed representation of the results will be option 3. Okay, let me check what is this page. So, I see some system information, page header, and the actual content of the page. From this info I can say that this is a GAM page, Global Allocation Map, which controls allocations in the database. And this approach is not very good for troubleshooting such kind of contention issues. First of all, the DBCC page requires sysadmin permissions. Why? Because if this will be not a system page but regular index or data page, we will see the actual data, which is not always allowed and which can be very bad to see that data. Second one, I need to run the DBCC page for each page which I'm interested in. And I can't react very quickly on these contention issues. Yes? Right now, if I will check my queries, this contention gone. And I'm not able to troubleshoot further, to check other pages. And SQL Server 19 gives us some alternative, which called DB page info function. It used all together with page res cracker function. Page cracker used to get the actual DB ID, file ID and page ID separate parameters from our page resource. And let me show you what I will be able to get with this approach. So, let me run it. And here is my contention. I clearly see that this is a GAM page. If this will be database page, I will see table ID, index ID, and will be able to quickly get the root cause of this contention and then work with that information. Also, with this approach, I able to do complex queries on this data. I will find all the queries which are waiting in the large wait and will group by page type, page ID, object ID, index ID, and now I see that 150 sessions are waiting in the large wait on this page 212. So very quickly I can get this information from the server on which pages we have contention, on which page we should check first of all. Yes, for this particular case, situation is the following. My tempdb has just a single file, and in this file we have global allocation map page. When new query which tries to create temporary table came to the tempdb, it will first go to the global allocation map to get its allocation. And this query put large on the global allocation map. If second query will want to make allocation too, it will wait until first query will not release its large. Once extent allocated for query 1, large is gone, and second query can take this page and make its own allocation. This is why contention happened in this example. For each database file, we have global allocation map chain. Each global allocation map page can index 4 GB of space. So it needs to be recurring after each 4 GB. If this GAM will be full, we will go directly to GAM2, GAM3, and so on and so on. And to fix this contention, in my case, I need to create several files for my TempDB database. In this case, my workload will be spread on all these 8 files, and I will not have this huge contention. For other cases, the solution can be very different, especially if that will be database tables or indexes. But with this approach, with this new function, DMDB page info, you are able to quickly get to the root cause and work in the correct direction with the resource which requires your attention first of all. And this is really cool feature. I already saw several examples where I think, heck, if we will have SQL Server 2019 here, we will be able to troubleshoot this issue much faster. Our next topic will be ideal workers count. And to go with that, let's recap how query is executing on the SQL Server. So, first of all, connection created, then session created, requests. Request actually is our query, which will be executing on the server. So, for each request, SQL Server creates one or several tasks. It depends on the query parallelism. For each thread in that query, for each task, we need to take a thread from the pool. It's also called worker. This worker can be in 3 different states. First one is running, which means that worker get all the resources required and the CPU. Second one, suspended, which means that thread is not consuming CPU and it's waiting for some resource, for log, fetch, inserting data to the transaction log, and so on and so on. And third state is runnable. When query got its resource, like log was released, this query put its own log, it's going to the runnable state and waiting for the CPU to execute. CPU on the SQL Server level, CPU scheduling is done with the schedulers. Yes, and for each logical CPU, we will have a separate scheduler in SQL Server. This is how it looks like. Query number 0 is going to schedule number 0. Query number 1 is going to the scheduler number 1, and so on and so on. Time quantum for each execution is 4 milliseconds. If query finished faster than 4 milliseconds, scheduler will take next query from the runnable queue. If query is executing for more than 4 milliseconds, it will go to the end of the runnable queue. And this is important. You remember that query 1 was executing on the scheduler number 1. So, in the following situation, when scheduler number 3 is free, in all SQL Server version before 2019, this scheduler will not take query number 1, because query number 1 was executing on scheduler number 1, and it will wait until it will be free again. So, this is not very efficient way of execution, isn't it? And in SQL Server 2019, new approach was introduced. Let me show you this. In the view DMOS schedulers, you can find a new field which called ideal workers limit. And for my active schedulers, it will be something about 80. Yeah. One more column was added to the view DMOS workers. And here you will see worker migration count. This actually means the situation when worker migrates from one scheduler to another one, which allows the queries to execute, which allows SQL Server to use CPU time more efficiently. Currently in SQL Server 19 it works only for system queries, but I think that this approach is very promising and it might be used for user queries in the future versions. And the fourth hidden feature from our list is reduced recompilations. Please look at these two procedures. First one, get top tweets, create temporary table, and then execute another inner procedure. In that inner procedure, we insert in some data into the temporary table. I have added this condition to slightly increase the recompilation time. And then in the outer procedure, we are selecting data from this temporary table. In the SQL Server up to 2019, the inner statement will be always recompile, because SQL Server doesn't trust the outer scope. That outer scope was not changed, the table definition was not changed. And in SQL Server 2019, Microsoft has added few lightweight checks to check if outer scope was changed between the executions of the inner procedure. And this helps to avoid unnecessary recompilations. In this demo, we will run the following workload. We will execute this procedure get top tweets 600 times on SQL Server 2017 and on SQL Server 2019. And then we will check performance counters, processor time, batch requests per second, and SQL recompilations for these two workloads. Let's start. 2017 workload. (2019) workload. And now let's compare the results. So this is CPU time for 17, this is CPU time for 19. You see that it is less CPU time spent on SQL Server 2019 for this workload. Batch request per second. At SQL Server 2019 it's up to 188. On SQL Server 2019 it's 382, almost twice bigger than in SQL Server 2017. And if we will check recompilations, on SQL Server 2017 at max it's 94 recompilations. For SQL Server 2019 it is 1 recompilation here at the beginning. And this is the place where we are not spending additional CPU for unnecessary recompilations. So this is the feature. This is a benefit which we are getting by default just by upgrading to SQL Server 2019. Wow, it's pretty small, but very useful and very good to know, because I know several projects where this feature will be very useful. And finally, we are coming to the last hidden feature from the list, compatibility level. And I can say that this is definitely my favorite one. When SQL Server builds the query plan, it highly relies on the statistics. Statistics for the columns shows SQL Server the data distribution and generally how much data is in each range. For example, for the following query, select stuff from users with ID between 2100 and 2500. SQL Server will look at the statistics histogram and will see that there should be about 10 rows. And SQL Server will build query plan based on this assumption. Probably there will be index seek here. But if the query will be like this, select stuff from users with ID between 200 and 5000, SQL Server will understand that this is almost the whole table, and he will build the query plan based on this knowledge, and probably there will be index scan. So it's pretty simple for SQL Server to get statistics for particular column and build a query for particular table. But if our query will be a bit more complex, at least with one join, SQL Server will have to do some more job here. Let's check the following query. Select stuff from users, inner join posts on owner user ID and where display name like Jeff. This is Stack Overflow database and tables users and posts, which contains the data of answers and questions and users who ask that questions or do answers. Okay. For the filter username display like Jeff, there is a statistics on display name and table users. And probably Jeff will be somewhere here. Yeah, between G and L. And SQL Server more or less can estimate how much rows this predicate will return. But then SQL Server need to find the IDs for the records filtered by display name like Jeff. And SQL Server do not have exact information about which IDs that will be. And then he need to join that IDs with the owner user ID on posts table. And here SQL Server came to the area of uncertainty. SQL Server understand the density, some overage values for these ranges, but he need to join pretty different ranges, and there is a very high variation here. SQL Server do pretty good job, but this process, honestly, the process of estimating rows called cardinality estimation. And these cardinality estimation rules changed very significantly in SQL Server 2014. So, old cardinality estimator, which was used in SQL Server before 2014, right now called legacy cardinality estimator, and current cardinality estimator, which used after 2014, has a name of default cardinality estimator. Okay, now we are coming to the demo. First of all, I would like you to show the differences in the cardinality estimation. For this demo, I will use the following query, which just selects data from several tables in the Stack Overflow database, use some filtering, grouping, and I'm forcing order with option force order for each of these queries. They are all the same. To force SQL Server to join the table in the same order, to show you this difference. And for each query I will use different compatibility level. First one will be run with compatibility level 110, which is SQL Server 12, then SQL Server 2014, and then SQL Server 2019. Let's run these three queries. So, this is the first one. We join table users and table batches. With legacy cardinality estimator, you see, actual amount of rows is 1700, but estimation is about 6000 something, which is not quite close. For SQL Server 2014 compatibility level, for SQL Server 14 compatibility level, there will be more accurate estimate. Again, 1700 rows, and estimate is 1900 rows, which is much better, yes? And for SQL Server 2019, estimate will be the same because the same cardinality estimation rules used here. There are three major rules documented, and this shows just one of them. But definitely what we know from this, what we learned from the previous experience of upgrading to SQL Server 2014 and later version, that for biggest amount of query plans, for biggest amount of queries, this will be positive changes. Yes? But there will be always some queries for which legacy cardinality estimator works better. And I will show you these queries in this demo. So that's slightly different query, but I used the same approach here. I set compatibility level to 2012, 2014 and 2019. These are the execution statistics. Legacy cardinality estimator, 3,700 milliseconds execution time. New cardinality estimator, 2,300 milliseconds execution time, which is much better. And then SQL Server 2019, who uses the same default cardinality estimator, executes this query in 1 second and spend twice less CPU time. Wow, that's cool. I will show you a bit later why this is happening. So, and this is negative example. Also different query. I will run it with different compatibility levels and we will check the statistics. With legacy cardinality estimator, this query executes for 300 milliseconds. With new cardinality estimator, it's a bit worse. It's almost 1.5 seconds. And for SQL Server 2019, with also default cardinality estimator, the execution time is 585 milliseconds, which is still not so good like legacy cardinality estimator, but much better than compatibility level of SQL Server 2019. So, what is the secret here? What is the difference? Let me show you this. Difference is over here. Adaptive join. On SQL Server 2019, if database compatibility level is set to SQL Server 2019, which is 150, SQL Server is allowed to use adaptive join and choose the join algorithm, hash join or nested loops, on the fly, which is really cool, and this is really big game changer. So, you saw from these examples, it can be much better, it can be not that bad, but definitely this is better than the previous one, compatibility level 2014 and also 2014-16 SQL Server versions. Okay, that's cool. And I want to show you one more cool feature in this demo, which allows us as database developers to choose various options for query tuning. So you can choose for database compatibility level 2110, 120, 150, but then it comes to a query execution. And for example, these two queries will be a bit different. Anyway, the old cardinality estimator works better. It's 300 milliseconds. Database has compatibility level 150, which means that this query will be executed in 600 milliseconds and spend much more CPU time. What if we want to keep the database in compatibility level 150 but tune just this simple query? In SQL Server 2019 we have options for this. And now I'm talking about use hints. These are the hints. Some of them were added in 2016, some of them were added in 2017. But this one, actually this is why demo came to the SQL Server 19 hidden features, because this compatibility level exists only in SQL Server 2019. But anyway, you have several options. You can use default legacy cardinality estimator hints for your query, but you also can quickly change to compatibility level of the single query without even thinking about legacy, default, cardinality estimator, all that stuff. You know the database, and this query works fine with compatibility level of database 110. You can just go to this query and hint it with compatibility level 110. And this query will execute for 300 seconds instead of 600 seconds, which is really cool. This can be considered as a temporary solution, like then you will optimize this query and it will work fine with compatibility level 150. But the fact that we have now a lot of options for query optimizations, for query tuning, for quick workarounds, this is really cool, and this is what making me really, really happy. I really love the changes which Microsoft does in SQL Server 2019, and I love all these small features which helps us to optimize query and do our work more efficiently. And now let's make a quick summary of what we have learned today. Lightweight query profiling, feature which was started in SQL Server 2014 and evolved through the time. In SQL Server 19 it's enabled by default and allows us to see the actual execution plans for the currently running queries, which opens almost unlimited opportunities to troubleshoot the queries. Last known query plan allows us to check the actual query plan for the query which has already been finished. DBCC page. In this area, Microsoft added new function DB page info, which allows us to get the information about pages, which is very useful in troubleshooting contention issues, slice and dice the data to get the important information about which objects are the hotspots right now. Ideal workers count. Very interesting feature which allows processes to not stick to the current worker and current CPU, which allows processes to migrate on different CPUs. Currently it's working only for system processes, but I hope in future it will enable for user processes as well, because it looks very promising. Reduced recompilations. In SQL Server 2019, Microsoft removed one case where recompilation is not required. This is when the table was created in outer scope and then inner procedure works with that table. Right now SQL Server 2019 checks the outer scope, if it was changed or not, and remove this unnecessary compilation, remove unnecessary CPU usage. Query Optimizer compatibility level, my favorite hidden feature because it allows to play with a lot of things. You can set compatibility level on database level, you can set compatibility level on a query level, and you can play with these options to find the best possible combination for your database, for your queries, and for your workload. And at the end, I would like to quote Anton Chekhov again. If in Act 1 you have a pistol hanging on the wall, then it must fire in the last act. If the hidden feature is there in SQL Server, it will become useful for you someday, sometime. And in any case, if your hidden feature will fire or will not fire, you can ask me questions about hidden features and about other things in SQL Server using any of these channels. Thank you.